50% of the teacher's desk is covered in exams. What is the probability of spilling coffee on them? And I have my coffee right here. Half and half. Get it? I got some half and half in my coffee. All right, let's go ahead and get started on probability rules. And first of all, I'm going to be talking about conditional probability, and you sort of already seen this, but I want to give you the formula for conditional probability. And the way we read this is probability of A given B. So if B happens, what's probability A will happen? Kind of weird I did it in that form, but it'll work. All right, so recall that the probability of B happening and A happening, it's kind of like B then A, is the probability of B times the probability of A given B. All right, where B is the first outcome and A depends on B. Well, if I'm trying to solve for this, I just have to divide both sides by the probability of B, and that gives me the formula. Probability of B and A all over the probability. So the way I tend to remember it is I just tend to put both of these together and divide by the probability of the second one. All right, so we're going to go ahead and take a look at some Venn diagrams before we practice with conditional probability. They're used to represent actual counts or percentages for different outcomes. So in this case, I have a bunch of sophomores at Cedar Ridge. Some are in geometry and some are in algebra 2. And in fact, there are some students, because they're trying to get on track and get more math credits, they'll take geometry and algebra 2 at the same time. So we're going to determine the number of sophomores in geometry and algebra 2. So if you look at this, who is in both of these? The 23 people right there. Now, the number of people and number of sophomores in geometry, it's tempting to say 452, but we also have to count these 23. So when we add those together, we get 475. Same thing's true for algebra 2. It's not just the 154. We have to count that 23. And in this case, we get 177. Now, here's the tricky one. Number of sophomores in geometry or algebra 2. It's really tempting to add these two together, but we have to make an adjustment. And why is that? Well, you see I'm subtracting 23. Why? 23, those 23 students are in this 475, and they're also in the 177 algebra 2 students. So they're being double counted. Now, if I wanted to know the total number of sophomores, that would be 629, and I want to teach you how to read this number. That's 47 who are not in geometry or algebra 2. They could be in calculus, pre-cal, or some other math. So that one, I just have to add those 47 to the total that I have here. Now we're going to go ahead and calculate some probabilities. Probability a sophomore is in geometry. Well, all that is this group of sophomores here over the total, which we said was 676. So we get 0.703, or about 70.3% of geometry sophomores are in geometry. Now this one is interesting. See that given right there? So when you have given, let me go ahead and highlight that. When you have the word given, that means that for sure we know they're in algebra 2. So my total, it's going to be students who are in geometry and algebra 2, because they have to be in algebra 2. It's given, but I also want them to be in geometry. Out of how many students? Well, I'm only looking at algebra 2. So that's how I'm going to calculate it. So how many students are in geometry and algebra 2? That would be the 23 right there. Out of what total? This total right here. So 23 out of 177, or about 13%. Okay, the probability of sophomores in algebra 2. Well, algebra 2 would be all of this area right here. So it would be the 23 plus 154 over 676, or about 26.2% probability. Now that is in algebra 2, given that they're in geometry. Now see, this one is just switched from the one above it, and we know that they're in geometry. Remember, all these people are in geometry. So that's going to be the number underneath. That should be a vertical bar there. All right, And how many of those people are in geometry and algebra 2? That's that little piece right there. So it's 23 out of 475, or 0.048. Probability of sophomores in geometry and algebra 2. Well, only these 23 right here are in geometry and algebra 2. So 23 out of 676, or about 3.4%. How about geometry or algebra 2? Well, if we can count up our geometry kids plus our algebra 2 kids, but remember we have to subtract double counting. So here I had 475 plus 177 minus 23 out of 676. Now I could have just added up the three groups here, because see how that's the double counted group, and that would give me the same answer. And when I get 629 over 676, about 93%. Now we're going to look at an example. Miss Wu teaches geometry and algebra 2. The probability that a student will get Miss Wu for geometry is 0.18. The probability that a student will have Miss Wu for geometry and for algebra 2 is 0.03. What is the probability to the hundredths that a student will have Miss Wu for algebra 2 if they had her for geometry? The easiest way to do this, first of all, we know the probability of Miss Wu for geometry is 0.18. Probability for Miss Wu for geometry and algebra 2 is 0.03. It helps to write down, and for some reason it changed some of my bars here. Those are supposed to be vertical bars. Algebra 2, given they had geometry, is that formula we just showed at the beginning of the notes. The probability of both given the probability of geometry. So substituting in the numbers 0.03 over 0.18, it's 1/6, or about 0.167. And if I were to do a Venn diagram here, you could say geometry, and there's algebra 2, and here you have 0.03, and this is 0.15. So it's this piece out of that whole. That's what we're trying to say. All right. In fact, that's what I was trying to say right there. All right. Now, tables can also be quite helpful for probabilities. And here I have set up a table with Cedar Ridge graduates who have taken geometry and algebra 2 because they met the requirement for, the minimum plan, and or the basic plan or the recommended plan, whatever it's called. How many students took geometry? Well, regular geometry. We can say 435 took regular geometry. That's these people right here. How many took pre-AP? Add those numbers, and I get 221 pre-AP geometry. How many took regular algebra 2? 476. And how many took pre-AP algebra 2? 180. So the total of graduates that I'm looking at is 656. It kind of looks like my last total, but it's not the same. So what's the probability that one of my graduates took pre-AP geometry? I'm not too worried. These are particular cells like algebra 2 and geometry, or pre-AP algebra 2 and regular geometry. I just want geometry, so I want this one right here. And that would be 221 out of 656. What's the probability they took pre-AP algebra 2? Well, that would be this column right here, and that would be 180 out of 656. Now let's go ahead and do some more examples. What's the probability they took pre-AP geometry and pre-AP algebra 2? Well, the only people that took both are those 157 people. So it'd be 157 out of 656, or 0.239. Now, could I say if I multiply the probability of pre-AP geometry times the probability of taking pre-AP algebra 2, would I get the same answer? Because this is an and. It's a little tricky here, because what's going on is if I multiply them, I actually got a 9% probability. And why or why not? We call this dependence. The events are dependent. Pre-AP students tend to take all pre-AP math. So if you take pre-AP geometry, you tend to take pre-AP algebra 2. And especially if you don't tend to take pre-AP, you usually don't slip into pre-AP later. Normally you tend to say, oh, okay, I'm done with pre-AP. I've had enough. I'm going to take it easy now. You don't tend to say, oh, I've been taking regular math. Now all of a sudden I want to take a lot harder math and it's more difficult. Okay, so let's look at the probability they took pre-AP geometry or pre-AP algebra 2. So pre-AP geometry or pre-AP algebra 2, how many people took that? Well, that's this group right here, right? And I think I'm going to circle that again. So basically, I'm using the formula here where I add geometry plus algebra 2. See, there's 221 right there, plus algebra 2. And what am I doing? I'm taking out the double counts of 157 because that 157 is making the 221. And it's also making the 180. So I have to take out my double counts, which explains why I can't just add these probabilities. Here I get a 61% probability they get geometry or algebra 2, but that doesn't work because the 157 students who took both are double counted when we just sum it. So basically, we don't want to include those. All right, so let's go ahead and look at the probability they took pre-AP algebra 2, given they took pre-AP geometry. And my software is messing up my bar. This is a vertical bar. Okay. So first of all, notice I get 157. So who took pre-AP algebra 2, given they took pre-AP geometry? Why do I have 157? Well, my universe is students who took pre-AP geometry, all right? And out of those, how many took pre-AP algebra 2? 157. Out of how many total? 221. Okay. Then what's the probability they took pre-AP geometry given they took algebra 2? So let me change my colors. In color, we'll go purple. So that's this world right here. So again, it's still the 157 because it's in both columns. But my total of students who took algebra 2 is 180. I'm not in this yellow line anymore, a yellow highlight. I'm in this purple highlight. So the probability a student took pre-AP geometry given they took pre-AP algebra 2 is actually 87.2.